Welcome to this session on the demonstration of the Triptych tools that are included in the SDI Tools software. In this discussion, we will be discussing effective tools for requirements and concept development, and primarily focusing on the use of the TRIZ, or the Theory of Inventive Problem Solving tool. The SDI Tools software includes the Triptych tools, which are very beneficial for a lot of activities that occur during requirements and concept development. In this discussion, we'll be focusing on the TRIZ tool that can be used to help you to develop alternatives to support different approaches to solving your stakeholders' requirements. The Triptych tools include a suite of tools that will assist you in addressing the voice of the customer, innovation or alternative selection, which will be the focus of this discussion, and then also design selection to determine the best solution among a set of alternatives. We've already discussed concepts related to understanding the problem, organizing ideas, identifying needs and wants using affinity diagram techniques, and then using the analytical hierarchy process to prioritize these needs and wants, and then using quality function deployment, or QFD, to help us understand how we can effectively address and accomplish the needs and wants of the stakeholders and develop critical requirements for your potential solutions. In this discussion, we'll be looking at ways to create alternatives. While there's many techniques that are available, the one we're going to focus on is an innovation technique that's called TRIZ, T-R-I-Z, or the Theory of Inventive Problem Solving. Subsequent to this activity, once you have determined or identified various alternatives for solving a problem, then you'll need to be picking the best solution, which can be performed by identifying the criteria that will need to be supported in the solution, prioritizing this criteria, and then applying any one of several design selection or alternative evaluation techniques that are available. And then finally, once you do have a solution, you should probably go back and reassess the risk of your potential solution with respect to the degree to which you can satisfy your stakeholder requirements. And this risk identification can be performed again by repeating your failure modes and effects analysis process. TRIZ is a method for generating inventive solutions to a problem where you have conflicting engineering requirements. The TRIZ method has been developed and is based on patterns of innovation that have been identified in various patents and patent applications. The TRIZ method is based on identifying a technical contradiction for your particular problem, determining the feature in this contradiction which you're trying to improve, and the feature which leads to a degraded or worsened condition. And then you can apply the TRIZ technique to choose from a set of design parameters, identify one that most closely matches your improving feature, and also a design parameter which closely matches the degraded feature in the particular contradiction that you're addressing. Then the TRIZ method is based on examining a set of proposed inventive principles, and then selecting from the best inventive principle, identifying potential solutions, or apply that inventive principle to your technical contradiction for the purpose of coming up with a solution to your problem. So TRIZ is based on identifying contradictions, translating your problem into a TRIZ general contradiction, choosing the best TRIZ general solution, and then extending that solution to a specific solution that will help you address the problem that you're trying to come up with to a solution for. So in the SDI tools, there is a TRIZ tool that will allow you to implement this process and basically support you in identifying design parameters and also inventive principles that could be applicable to your particular problem. Now, the design parameters and inventive principles that are included in SDI's TRIZ tool are those developed by Jean-Ricard Schuler in his TRIZ method, and those that were investigated as part of his contradictions matrix. And in the tool, we've included the 39 design parameters that are typical or based on Schuler's work, the 40 inventive principles, and then supported those with 130 definitions and 167 examples that you can use and evaluate to help you come up with a solution to your problem. So let's go investigate how the TRIZ method can be implemented using the SDI Tools Triptych software. Here we're in a standard Excel workbook where we have the SDI Tools Triptych software enabled as a add-in within Excel. And what we will do is go to the new worksheet, and we'll identify then where we can select the TRIZ method, which is on the Innovation tab of this new Triptych worksheet window. We'll select the TRIZ session and open this. So here we have a basic template, which will be the output report, which eventually, once we go through the process, will contain information related to the TRIZ contradiction that you selected, the TRIZ generic solution that could be applicable to overcoming this contradiction, and then the ideas that you generate to help you come up with a solution to the project contradiction that you are investigating. So the first thing we will do in this process is we will enter in up here in this window the project contradiction. Now, in continuing our discussion that related to prior tutorial sessions on the Triptych tools, one of the key pieces or tool we began with was the affinity diagram tool, which is basically a technique for collecting information, sorting that information, and then using it to identify the key areas that you can focus on to support your problem solving, your development activity. So let's define a project contradiction that is somewhat related to the objective of the affinity diagram tool, and see if we can use TRIZ to identify the key aspects of what would be needed to solve this problem. So the problem we're going to address, or the contradiction, is that due to the amount of stakeholder information, it is hard to determine where to focus. So this is a typical problem-solving dilemma that we could be dealing with, and basically which is the objective of the affinity diagram tool. But let's see what candidate approaches the TRIZ might offer in addressing this problem, where we have a lot of information. We're trying to sort through the information, determining where to focus to come up with a solution to our customer's problem. So to start the TRIZ session, we're going to come up here to the Triptych toolbar and click on the light bulb icon, which is for the TRIZ tool. So we will open this, and what we see is that our problem contradiction is entered into this top field in this first area, which needs to be defined in the to start the TRIZ process. So you can work this either of two ways. You can open the TRIZ tool first and type in your problem statement, and then you can move it over to your TRIZ session, which is in the workbook, or you can enter your problem statement in the TRIZ session workbook, and it'll automatically be entered in the TRIZ tool we'll be using here. Now then, what we need to do is identify the feature we're trying to improve. Okay, and what we're trying to do is maximize our how we can extract information from a large amount of information. So let's say that the feature we're trying to improve is basically limiting our loss of information. So in the TRIZ concept, there is a standard list of 40 design parameters which are available to you for you to select from here in the design parameters for the features you'd like to improve. And so let's go down for this problem. Let's say that what we're trying to focus on is improving the loss of information. We don't want to lose more information. We want to mitigate the loss of information. So let's select this as a possible design parameter to improve. Now, at the same time, in preventing this loss of information, a degraded feature may be something limiting our ability to really see what is important to us within all of this information we're examining. So what we can do is now go back through the list of the subset of the list of 39 design parameters that apply to the loss of information, and that's what's applied here. So I'm going to go down through the list to number 37, difficulty of detecting and measuring. So maybe it's difficult to detect what we really have to go do in this large set of information from which we're trying to minimize our information loss. Okay. Now then, having defined these, if you're a little confused or not really sure what these two mean, there's a little question button over here that we can click on, and it will tell us that loss of information is degree or elimination of data or input from a system. And then difficulty of detecting and measuring can be looked at as being the quantity and diversity of elements used in measuring and monitoring all an object or system, as well as the cost of measuring an acceptable error. Okay, so we're trying to focus on the error, I guess, here of identifying what's important to focus on. Now, having selected these two design parameters, in this case there are two generic TRIZ inventive principles that could be applied to this. One is homogeneity and the other is changing parameters. Okay, well, let's start with the homogeneity principle first and see if we could apply this principle to overcoming this contradiction. Okay, so one definition of homogeneity is to make objects interacting with a given object of the same material, and a definition here is to make a container of the same material as the contents to reduce chemical reactions. Now then, basically what we'll be looking at or be thinking about here is that take things that interact with a given object, make them out of the same material so that they don't interact. Okay, so basically it's how do we arrange our information. So maybe in examining this information and the definitions and examples here, let's say that an idea comes to us of really what our difficulty is due to this large amount of stakeholder information in determining where to focus. And let's say that what we realize is that really the problem is to group the information in categories related to functions performed. Okay, so let's take this as a candidate approach, as something we realize we can do here by in a way that we group the information that could be beneficial to us. So once we capture this idea, then we can click the Save button, and this information that was captured in the TRIZ tool will be moved over into our worksheet, and we have we saved the idea we came up with along with information that might have led to the identification of this potential project idea. Now we can continue the process. Let's don't just stop here. Let's go look at change parameters and see what possible definition examples come up from this inventive principle. Well, we could change an object's physical state as one definition, change the concentration or consistency. Liquid hand soap is concentrated and it gives you other effects than you get with typical bar soap type applications. So once again, just kind of a generic definition. Now let's say here that changing the concentration or consistency may lead to some ideas related to how we can use this. Change the degree of flexibility could be another way of looking at this. Changing temperature, but there's a variety of ones that we could examine. And maybe as we look at this and about changing concentration or consistency, maybe we need to start thinking about how we segment the information or group the information that we're going to look at in categories. And maybe one approach now is to group information in categories related to either parts of the product, such as the categories related to inputs or outputs or other areas of the product, or the group the information categories for the complete product. And things related to complete product could be cost, power, schedule, things of this type. So do we break this information down that we have into things related to specific areas of the product, parts of the product, or do we take the information and categorize it based on different things that relate to the complete product, things related to cost, things related to power, schedule, and so forth. So this is one way we could take this large amount of stakeholder information and help us determine where to focus on different parts of the product or focus on different aspects of the product. So let's save this information, and now this is moved over, and we see now we're still looking at the loss of information, difficulty detecting and measuring, now changing parameters, and it's led to this idea about how we group the information. Okay, now let's continue on a little bit more, and let's look at maybe another way to explain what we're trying to improve is what is being degraded. And let's go back and re-examine some of the other design parameters. And one we may want to consider is the quantity of substance or the matter. So the quantity of information could be what we could relate to this. And if we look at what this is, the number of elements, or the quantity of an element used to create the object of the system. So the quantity of information we're going to use to help us define the solution to the problem is one way of looking at this. And then the degraded feature we're going to look at, well, let's go back to the same one we had before, which is the difficulty of detecting and measuring. Okay, and now you see that there are different inventive principles that could be applied to overcoming this particular contradiction, but it could still be related to our basic overall contradiction, our problem we're trying to address in this case. So let me go to mechanical vibration, and looking at some definitions: cause an object to oscillate or vibrate, increase the frequency that we do something, way we distribute powder with vibration, things like this. It's kind of just generic examples, not necessarily applying to our problem, but just generic ways of applying this concept. And if we think about the increasing the frequency of doing something, well, an idea that could come out is let's study a small group of information for a short period of time. So just a kind of a quick look sort of thing. Let's summarize it, and then move on to another group. Of information. Okay, so once again, just by thinking about this, mechanical vibration, the frequency at which we do something, dividing things up into segments, well, let's apply this to our information and see if that would help, and then we can add this to our template that we're creating. Okay, let's go back and let's look at local quality. Okay, and local quality, change an object's structure from uniform to non-uniform. It could be each part of a function in conditions most suitable for its operation. Make each part of an object fulfill a different and useful function. Okay, like a pencil with an eraser, we have different parts and each part has a different function. Well, maybe this is what we need to do with our information, is let's go identify functions of our product that need to be performed to solve stakeholders' objectives. Objectives / problem, and then focus on the functions. Okay, so rather than looking at the problem as a whole, maybe what we need to do is look at the functions that need to be performed, and then we'll go address this, and then we can save this into our worksheet. And then maybe continuing on other ways to look at this is, well, maybe it's we have a lot of information, but what we're trying to do is mine this information or manufacture it in order to determine what to go do. So let's see if we can relate this to ease of manufacture. And we've got segmentation, cheap short life, pneumatic, hydraulic, change parameters. Well, under segmentation, we can divide an object into parts, and examples would be to a mainframe computer by personal computers, replace a large truck by truck and trailer, use a work breakdown structure for a large object. Maybe we need to take a work breakdown structure approach to this, and let's divide the information into categories and partition the project task based on identified categories. Okay, and we can save this one. Okay, so now then, once we're complete, we can close this window, and basically what we have is a set of project ideas that we could go use to address this project contradiction that we have a lot of stakeholder information, but it's hard to determine where to focus. Now then, the objective of the TRIZ session is not necessarily to come up with an approach that nobody has done before. It would be very valuable if that was the case. But also the objective is to come up with ideas to solve a problem which could have a lot of commonality with other things that have been done before, but for which we've we failed to see a logical approach in dealing with this problem. So now then, we see now that dealing with this information, that if we group the information, group it in categories, make the categories based on product functions, or make it based on overall aspects of the product, or maybe if we just change the way that we address the information, rather than trying to look at everything together, break it up in groups, study a group for a short period of time, summarize that, study another group, and continue on. And through this, we can identify maybe functions that need to be performed, and also then divide the information up to as far as how we go approach the problem. So a lot of different ways to use the TRIZ technique, and use the tool that's included in Triptych to basically facilitate this process and give you a way of basically brainstorming using the tool and coming up with ideas to solving a particular problem. So what we've tried to cover in this session is the use of a very simple tool as kind of an aid to help you identifying different ways to solve problems. There are different things you can do as far as editing and things like that, and putting the information in your worksheet, but basically it's pretty much just following a process and allowing you to think about different ways to go solve your problem. So in this discussion, what we tried to focus on is analyzing conflicting requirements in order to identify potential solutions. So you could use a technique to address processes. You could use it to address maybe a very technical area of a product, maybe a weight versus velocity, maybe power versus speed, maybe reliability versus temperature, many different areas that you could go investigate to look at ways to come up with technical solutions to a problem. You could look at it for ways to develop a process to address another condition. So they can be technical or non-technical type problems that you can utilize or investigate using the theory of problem solving in the TRIZ tool that's in the Triptych tool set. So I want to thank you for attending this session. I hope this information has been beneficial to you, to give you just an idea of what the TRIZ tool is within the Triptych tools and how you might utilize it. So if you want to investigate this further, please download the SDI Tools at stat-design.com. And if you have any questions on the application of these techniques, please feel free to call me or send me an email. Thank you very much.